In an infinite world of blocks, one of the best-selling video games of all time was born not in a giant corporate studio, but from the mind of a single Swedish programmer. If you've ever dreamed of creating your own game, the story of Minecraft, its creator, and its technology is a masterclass in how a simple idea can change the world. The man behind the blocks is Marcus Notch Persson. His inspiration wasn't cutting-edge graphics, but a childhood love for Lego and classic games like Dungeon Keeper. He held a core belief that hyperrealism actually limits imagination. By using simple, blocky visuals, he gave players a canvas, encouraging them to build, explore, and create their own stories in a world shrouded in mystery. After years as a programmer, Notch founded Mojang Studios in 2009 to bring his vision to life. The game's monumental success made him a gaming icon, culminating in the sale of Mojang to Microsoft for a staggering $2.5 billion in 2014, after which he stepped away from his creation. The technology that powers Minecraft is as ingenious as its concept. The game was developed in Java, evolving from early prototypes like Ruby Dung, which was a dwarf fortress-inspired engine test. The true magic lies in its core tech, procedural generation, which creates seemingly infinite and unique worlds for every player. This is combined with a voxel system, the fundamental blocky nature of the game that allows for unparalleled building freedom. Perhaps the most revolutionary element was redstone, an in-game material that functions like electrical wiring, allowing players to build complex logic circuits and automated contraptions. When Microsoft took the reins, the technology entered a new era. The development of the Bedrock Edition unified the game across multiple platforms, from consoles to mobile devices. More importantly, Microsoft began leveraging the massive amounts of player data for AI-driven insights, helping to guide content updates and recommendations. Its research division even uses Minecraft's sandbox as a training ground for advanced AI. Projects like Malmo and MineRL challenge intelligent agents to learn and solve complex tasks within the game's world, pushing the boundaries of artificial intelligence. Meanwhile, the community continues to push the in-game tech to its limits, using redstone to build everything from simple automatic doors to fully functional processors the size of virtual skyscrapers. Minecraft's journey shows that you don't need a billion-dollar budget to start a revolution. It began with one developer's clear vision, a focus on creative freedom over graphical fidelity, and technology that empowered players instead of just impressing them. For anyone aspiring to build the next great game, the lesson is clear. Find your simple, powerful idea and give your players the tools to make it their own. There are moments in the history of technology that feel like cosmic shifts, where the universe of what's possible expands in an instant. Imagine two figures standing at the precipice of such a change. One, a man in his 30s, short blonde hair, a trim beard, favoring a bright orange shirt and jeans. This is Gabe Newell. Beside him, his colleague, Mike Harrington, with dark hair, glasses, sharp and clean-cut in a business suit. In 1998, these two former Microsoft employees embarked on a journey that would reshape the digital landscape forever. They founded a company called Valve. Gabe Logan Newell wasn't just a businessman. He was a visionary who saw the future of entertainment not in a box on a shelf, but as a current of data flowing directly to us. He and Harrington, using the wealth they'd accumulated at Microsoft, set out to build not just a game, but an entire ecosystem. Their first creation, Half-Life, was a revelation, a masterpiece of interactive storytelling. But the true revolution was yet to come. It was an idea called Steam. Think about the technology behind Steam. It wasn't just a store. It was a digital distribution platform, a social network, and a direct line from creator to player, all woven into one. In the early 2000s, this was a radical concept. It leveraged the growing power of the internet to bypass traditional publishers, allowing for automatic updates, community hubs, and a library of games tied not to a physical disc, but to you. This was the moment the billion-dollar gaming industry pivoted on its axis, a silent explosion of code and connectivity. For the young minds watching this, those who feel the gravitational pull of creation, this is your call to action. The universe of code, of artificial intelligence, of game design is vast and waiting for its next explorer. Like a young Gabe Newell, you can start now. Learn languages like C++, Python, or C#. Dive into game engines like Unreal or Unity. Explore the frontiers of AI and machine learning. The path into this industry is no longer a hidden trail. It's a superhighway of online tutorials, open-source tools, and collaborative communities. The story of Gabe Newell and Steam isn't just about video games. It's a testament to the power of a single, bold idea. It's a blueprint for seeing a future that others can't, and then building the tools to make it a reality. The next great digital cosmos, the next Steam, is waiting in the imagination of someone right now, learning their first line of code. The question is, will it be you? Picture this: February 2005. 3 friends, Chad Hurley, Steve Chen, and Jawed Karim, are frustrated. They just had a great time at a dinner party, but realized there was no easy way to share the videos they took. That single pain point sparked a billion-dollar idea. Their solution: a simple website where anyone could upload and share their home videos. They called it YouTube. At first, it was a struggle. People weren't sure what to make of it, but soon the idea caught fire. The very first video, Me at the Zoo, posted by Jawed himself, was just the beginning. Within a year and a half, their little project had exploded into a cultural phenomenon. It grew so fast that Google noticed and, in 2006, acquired YouTube for a staggering $1.65 billion. From a dinner party idea to a global giant, that's the power of solving a real problem. So, how does this digital beast actually work? What's the secret sauce that lets billions of us watch videos at the same time? It's a technological marvel built on Google's massive infrastructure. Think of it like a master chef's kitchen with specialists for every task. For its main structure and high-traffic services, YouTube relies on powerful languages like Java and Python. For the really heavy lifting, like processing and encoding every single video you upload, they use the speed demon, C++. And to make sure the site is fast and responsive, Google's own language, Go, handles a ton of the networking. Of course, what you see, the player, the buttons, the comments, that's all crafted with CSS, JavaScript, and HTML5. But where do all those pet videos and tutorials live? They're stored on Google's colossal distributed file systems, like Colossus. And the data about those videos, the titles, descriptions, and your user info, is managed by a system YouTube actually created and open-sourced, called Vitess. It's a genius way to scale databases. When you watch a video, it's not coming from a single server in California. YouTube uses a global network of servers, a CDN, to bring the content physically closer to you, which is why you get smooth playback instead of endless buffering. The real magic, though, it's the artificial intelligence. That homepage, perfectly tailored to you. That up next video you can't resist clicking. That's the work of a powerful recommendation engine. It's a deep neural network that analyzes everything. What you watch, what you like, even what you skip, to predict what you'll want to see next. It's constantly learning and evolving, creating a unique, personalized channel just for you. From a simple idea to a complex ecosystem of code, servers, and AI, YouTube is a testament to what's possible when you combine a great idea with world-class technology. It empowers creators and connects the world, one video at a time. What problem will you solve next? Thanks for watching, and don't forget to subscribe for more deep dives into the tech that shapes our world. There are more powerful computers in human pockets today than existed in entire buildings just a few decades ago. One object reshaped communication, photography, navigation, entertainment, and computing itself. Not because it was magical, but because it was engineered. This is the iPhone. At first glance, the iPhone looks simple, a rectangle, glass, metal. But that simplicity is an illusion. Inside this thin slab lives one of the most complex machines humanity has ever mass-produced. At the center of everything is the system on a chip. The iPhone doesn't have a CPU, GPU, neural processor, and memory scattered across the board. They are fused together into a single piece of silicon, measured in nanometers. Inside that chip are billions of transistors, each one a microscopic switch, on or off, 0 or 1. Together, they simulate logic, memory, vision, speech, and intelligence. This is physics turned into thought. Modern iPhones don't just compute. They recognize faces, translate languages, enhance photos, and predict behavior. That's handled by a specialized component, the neural engine, a processor built specifically to think in patterns. None of this works without energy. The iPhone's battery is a carefully controlled chemical reaction. Lithium ions flowing between layers, again and again, not exploding, not overheating, not failing. That stability is engineering mastery. The screen isn't just a window. It's millions of microscopic light sources, each one precisely controlled for color, brightness, and motion. Your eyes don't see pixels. They see reality recreated. An iPhone camera is not a camera. It's a sensor, a lens system, and a computer vision pipeline working together. Every photo is the result of dozens of algorithms running in milliseconds. Photography, without the photographer knowing. The iPhone constantly protects you. It detects crashes, monitors motion, encrypts data. It guards privacy at the hardware level. Security isn't an app, it's baked into the silicon. Each iPhone is assembled from parts sourced across the planet. Thousands of suppliers, millions of machines, micron-level tolerances. This is industrial choreography. The iPhone is proof of something important. The future isn't built by magic. It's built by engineers, electrical engineers, mechanical engineers, materials scientists, software developers, people who understand how the world works and bend it carefully. If you want to enter this world, here's the secret. Learn the fundamentals: electricity, mechanics, programming, physics. You don't need permission. you need curiosity and persistence. Future phones will think faster, see deeper, and last longer. New materials, smaller transistors, smarter AI. The devices will change. The need for engineers will only grow. Every time you touch your phone, you're holding centuries of science, decades of engineering, and millions of human hours of problem solving. You're not just a user. You could be a builder. The future doesn't arrive. It's engineered, and it fits in your hand. Thanks for watching. Follow for more. It looks simple. A black tower, a white box, no glowing lights, no aggressive curves. But inside the Xbox Series X and Series S is one of the most powerful real-time simulation machines ever built for entertainment. This is not just a console. It's a purpose-built supercomputer for play. Before power comes heat. Before speed comes airflow. The Xbox Series X is engineered like a compact workstation. Straight through airflow, a vertical chimney design, one massive fan pulling air across every critical component. Cooling isn't an afterthought, it's the foundation. At the center of both consoles is a custom AMD system-on-a-chip CPU, GPU, memory controllers, ray tracing hardware, all fused into one piece of silicon. This chip is designed not for spreadsheets, but for worlds that never stop moving. The CPU uses AMD's Zen 2 architecture, 8 cores, 16 threads, clocked for consistency, not spikes. Because in games, predictability matters more than raw bursts. Every NPC decision, every physics calculation, every frame timing decision, all start here. The GPU is where worlds take shape. Built on RDNA 2, the same architecture used in modern high-end PCs. Hardware, ray tracing, variable rate shading, mesh shaders. Light behaves like light. Shadows exist because something blocks them. This is math pretending to be reality. 2 consoles, 1 architecture. Series X targets maximum resolution and performance. Series S trades raw pixels for efficiency and accessibility. Same CPU, same SSD tech, same game logic, different scale, same future. Forget loading screens. The Xbox Velocity architecture streams game data directly from storage to memory at gigabytes per second. Textures, geometry, entire levels. The SSD isn't storage anymore. It's part of the memory system. Games don't just need memory. They need fast memory with predictable access. Shared intelligently between CPU and GPU, GDDR6. Memory feeds the system like a fire hose. No waiting, no stalling, just motion. Audio isn't an afterthought either. Dedicated audio hardware simulates sound bouncing through spaces. Footsteps echo differently in stone halls. Gunshots feel distant or immediate. You don't just hear the game, you're placed inside it. The Xbox Series consoles don't abandon the past, they enhance it. Old games load faster, run smoother, feel newer. This isn't nostalgia. It's preservation through performance. Even the controller is engineered for precision. Low latency, wireless, improved grip geometry, refined triggers and haptics. It's not just input. It's a feedback loop between human and machine. Hardware alone isn't enough. The Xbox OS schedules tasks, balances power, allocates memory. Every frame is a negotiation between silicon and software. When it works perfectly, you never notice it. All of this exists for one reason. So when you press start, nothing gets in the way. No waiting, no stuttering, no friction. just worlds that respond instantly. The Xbox Series X and S weren't built by magic. They were built by engineers, electrical, mechanical, software, thermal, people who love performance and hate wasted cycles. If you love games, this is one path to building them. The best games feel effortless, but effortless takes work. The Xbox Series X and S are proof that when engineering disappears, experience takes over. And that's when worlds feel real. Thanks for watching. We live in an age of instantaneous connection, an epoch defined by moving images shared across the globe in the blink of an eye. But how did this digital stage, this global theater, come to be? Like all great things, it began not with a bang, but with an idea, nestled in the minds of three young visionaries. Their story is a modern epic, written not in stone, but in pixels and code. Here is Chad Hurley, 28, his high, thoughtful forehead framed by blonde hair, an artist and designer who would give the platform its intuitive face. His gaze seems to look past the lens into a future he is actively building. Then there is Steve Chen, 26 years old, his eyes framed by glasses, a brilliant engineer from Taiwan. His expression is one of quiet intensity, the look of a problem solver, a digital architect who would construct the intricate scaffolding needed to support a billion dreams. He represents the technical prowess, the engine that would power this new vessel for human expression. And beside them, the third pillar of this creative triumvirate, Jawed Karim. At 29, his Bangladeshi and German heritage is reflected in his features. At 25, his Bangladeshi and German heritage is reflected in his features, his gaze direct and purposeful. It was his curiosity, a simple question of how can I share this video, that sparked the initial flame. It would be Jawed who would upload the very first video to the platform, a humble 18-second clip from a zoo. And completely unaware, he was laying the cornerstone of a media empire. These are not kings or conquerors of old. Their faces are not weathered by sun and battle, but they are the pioneers of a new frontier, a digital continent. They were young, they were brilliant, and they were working out of a garage, armed with little more than expertise and a shared frustration. They saw a void in the internet's fabric, a place for shared videos, and they resolved to fill this void. What they created was more than a website. It was a mirror to our world, a repository for our memories, our art, our follies, and our collective consciousness. In these still images, we see the calm before the cultural storm, the quiet architects of a revolution that would change, in some fundamental way, what it means to be human in the 21st century. Thank you for watching.